Hello, welcome back to the channel. So let's continue our previous video and do some more questions on calculating indefinite or definite integrals of trigonometric functions only in these type of questions. So in this question, we have to evaluate the integral of cos³ dx over here. And there are indeed multiple ways in order to solve for this integral, but in this case, we'll see how we can manipulate this integral and solve for this integral using substitution over here. Because when you will be using substitution in order to solve this integral over here, you would see that your calculations would become much simpler than calculating this original integral over here. So that is why now let's find a way on how we can evaluate this integral over here using substitution. So now we know that we have to calculate the integral of cos³ dx, but in order to use substitution, we generally want our function and the derivative of that function together, right? But in this case, we only have cos x over here. In order to use substitution, we need a sin x term over there as well, right? So that is why let's rewrite this indefinite integral over here and see what we can do with cos³ x so that we have an expression which will help us to see how we can add a sine component in this integral over here, right? So cos³ x dx can be simply written as cos² x cos x dx, right? And we know one more identity about sin² x and cos² x, that sin² x plus cos² x equals 1, right? And since we have a cos² x term over here, our cos² x from this expression, because we want a sin x term, a sine term in the indefinite integral over here, we can simply change this cos² term to something like a sin² term expression over here, right? By only using this property over here. So from this property, cos² x can be simply written as 1 minus sin² x over here, right? So now let's change this indefinite integral and substitute the value of cos² x in terms of a sine expression over here. So now we have integral cos² x cos x dx, and since cos² x is also 1 minus sin² x, this cos x will remain the same because we want cos x and sin x together in order to use substitution. So we will not do anything with this cos x dx term over here. And again we use the cos² expression over here. Cos² is basically 1 minus sin², and now this is your manipulated indefinite integral over here, and you'll clearly realize that you can simply use, in order to solve for this integral, you can simply use substitution in this case, because you have a sin x component and you also have a cos x dx component. So this gives us an idea that if we assume our u function to be sin x in this case, it will further simplify our expression and we'll get a very simple expression to calculate the indefinite integral for. So if we assume a u to be sin x, take the derivative of u with respect to x, we get cos x, right? And if we shift this dx over to the other side, we will get du as cos x dx. So now when we took u equals sin x, this expression can be changed to 1 minus u square, right? Because sin x is u, so 1 minus sin² x can be changed to simply 1 minus u square over here, right? And this cos x dx term can be easily changed to du, right? So let's do all the changes. If you do all the changes, you will basically be calculating the indefinite integral of 1 minus u square du in this case, right? Because if you do all your modifications, this will be changed to 1 minus u square, and this cos x dx term would be changed to du in this indefinite integral expression over here, right? And now if you want to calculate the integral, the indefinite integral for this one, this is very simple, right? It would just be, if you want the answer in terms of u, it would just be the integration of 1, which is u, minus the integration of u square, which is u cube by 3. And since you are calculating an indefinite integral in this case, you'll add the constant of integration as well, right? But now this answer, again, as we discussed in the previous video, this answer is in terms of u, but you want the final answer to be in terms of x over here, right? Because you were calculating your indefinite integral based on the variable x, so that is why you have to have your final answer in terms of x and not in any other function or any other variable form over here, right? So since our u was originally sine x, we'll change every occurrence of u to sine x over here, right? So this would become sine x minus sine cube x upon 3 plus the constant of integration in this case. And this will be your final answer and also the answer to the integral cos³ x dx over here, right? So that's it for this video. Again, in this video, we tried to solve the indefinite integral of a trigonometric function using substitution and also identifying the pattern on how we can manipulate our indefinite integrals and then use substitution in order to make our indefinite integral expressions simpler and easily calculate them rather than calculating the original indefinite integral using the normal methods over here, right? So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.